Welcome back. Let's now go over your solutions for the final field readiness exam. Let's begin by running this cell to import string and random, and then we will start off with our init method in our encryption class. So the first thing we wanted to do was set a random seed, and you can do that by saying random.seed, and then we're passing in a seed parameter, so we will go ahead and have that be user defined. Then we will say self.seed is equal to the seed parameter defined. So upon initialization or an instantiation of an instance of this encryption class, we've gone ahead and set the seed for our random library, and then we also mark it down as our seed. Then we're going to create an empty string attribute to hold the encrypted phrase. So we will say self.encrypted phrase and have that be an empty string. And then the next thing we're going to do is use the string and random libraries to create two attributes. One of them will be called the true alphabet, and we're just going to have that be string.asci lowercase, and we're actually going to have this be a list. That way we can play around with its indexing later on. And we will say self.randAlphabet, and that's going to be equal to, as the hint supplied, random sample, and we're going to pass in self.trueAlphabet by length of self.trueAlphabet. So let me zoom out here just a little bit so we can see that whole thing. And those are our attributes. So we have our seed attribute, an empty encrypted phrase that we will fill out later, and then the true alphabet, and then the random alphabet. The next thing to do is begin our encryption method. So we will start by having an output string that we intend to fill out later. And step one is to replace every other letter with a random letter. So we'll do the following. We'll say for, and we can zoom back in here, for I in range, the length of the message. And remember, the message is what's being supplied here. So you're going to pass in your message through the encryption method. So for I in range of length of message, we'll say the output, and we will add in message of I. And then we'll also say grab that same output, and then concatenate random, and we'll take in a random sample from self true alphabet, comma 1, 0. So let's see what's actually happening here. We've defined an empty string called output. Then, for I in range length of the message, go ahead and grab that empty string output and then concatenate message at index I, which is essentially just going to be the letter at that message. And then, right after you put in the letter of the message, you're going to take a random sample from your true alphabet. So you're going to grab one random letter. And because this is a list that is returned, you can go ahead and grab the first item in that list of 1. So that's why we have this indexing here. Because basically random sample, just to kind of show you here, will return something like this. So a list of just one random letter. So in order to sample off of this, we use that indexing of 0 to just grab that string so we can concatenate it on. Now there's different ways of doing this, but this is the one that is essentially showing the logic more precisely than some other methods. Again, there's many ways to do this. To reverse the string, what we can do is start defining our encrypted phrase. So we'll say self-encrypted phrase is equal to the output, and then we can easily reverse it with indexing using this method. The final step is to use the random shuffled alphabet for a Caesar cipher. Let's go ahead and delete the pass statement and begin to write that out. I'm going to create a variable called encrypted phase 2, and it's basically going to be a bit of a placeholder that we can add on to. So it's going to be a list, and it's going to go range length of self.encrypted phrase. So right now, self.encrypted phrase is our current message where we added in random letters for every other letter, and then we reversed it. And then what I have here is a list encrypted phase 2 that is essentially just all the numbers of how long from 0 all the way to the length of the encrypted phrase. So it's range here, and we created a list out of it. Range going from 0 all the way to the length of the self.encrypted phrase. So now that I have this encrypted phase 2 list, I can play around with it. So we will say for I letter, tuple unpacking here, and enumerate self dot, and we're going to grab our encrypted phrase, and we're going to make it all lowercase so we can do the following. We'll say if the letter is in self dot true alphabet, and the reason I check if letter in self.true alphabet is that way, in case I have punctuation, I can say something like else encrypted phase 2 at that point in I is just equal to the letter. So this is essentially only going to happen for punctuation, and spaces. So that's why I have this if statement. So I'm going for every letter and index position in my encrypted phrase, lowercase. And I'm going to check if that letter is actually in the alphabet, meaning I'm dealing with an alphabetic letter. I actually want to swap it for its Caesar cipher, which means we will do the following. We will say index is equal to self dot true alphabet, and I'm going to find the index location of the letter. And then we will say encrypted phrase 2 at index position I is now equal to self dot and my randomized alphabet at that index position. So this is the Caesar cipher in operation. What we're doing again here is if we actually have an alphabetic letter, find that index location in the alphabet, and then find the matching index location in our shuffled alphabet and do the reassignment there. Then what we're going to do is after this entire for loop is done running, I'm going to set self.encrypted phrase equal to, and I'm just going to join the phase 2 of it. I will say join encrypted phase 2. And remember, this basically takes this list and joins it as a string. And then what I can do after this is it's all done, so I can return self.encrypted phrase. So let's run this and see if our encryption looks like it's working. It's going to be hard to tell at first whether it's working or not because we would need to decrypt it to confirm that. But let's run this and see what we have. So I'm going to encrypt it with 20, and then we'll do the encryption of hello world. And if I run that, I get back the exact same result as expected. And let's kind of edit this a bit. So add in some random letters here, and we can see it's still working. And it looks like a completely different result. So it looks like a pretty good encryption method, at least for the very basics. And if we do hello world again, we can see we get this result. All right, now it's time for the decryption. And the decryption is essentially the exact same thing. It just reverses everything. So let's do that. We need a seed in order to set random. So we're going to say random seed. And then for this particular decryption session, we're going to have our randomized alphabet. So we will say session rand alphabet is equal to, and we'll say random sample. We'll grab from the true alphabet and then say do this for the length of true alphabet. We can zoom out here in case you want to see that whole line. Then after this, we're going to say that the decrypted message is equal to, and we're going to do a list, just like we did before, list of length message. And that's the message I'm trying to decrypt. So this is an encrypted message that's coming in. So keep that in mind. And then what we're going to do here is once we have that decrypted message list, we're going to undo the randomized Caesar cipher. So we'll say for I letter in enumerate, and this is essentially the same thing we did before, lowercase the message. If the letter is in the actual alphabet, then we'll do the exact opposite. We'll say that the index position is equal to my session rand alphabet, indexed at that letter, and then I will say my decrypted message at location I is equal to self.true alphabet at that index location. And then if I'm dealing with punctuation or something else, I'm going to say that my decrypted message of I is just equal to the actual letter. And then I'm just going to join this to bring it back into a string. So we'll say decrypted message is equal to, let's zoom in here so we can see a little better, is equal to join of that list. So we will join our decrypted message. And now if I have my decrypted message, I still need to do two things. So let's run this and see the two things I need to do. So my encryption of hello world, and if I pass in this code here with the seed 20, well, let's return our decrypted message just so we can actually see what the result is. Return decrypted message, run this, and I get back something that looks like this. So right now, I still need to reverse this string. I can see here I have HELLO. So let's reverse that, and I can simply reverse by using slicing. So let's just do : -1 off of this decrypted message, and then run these again, and I can see I've successfully reversed it. And now what I want to do is grab every other letter. So to do that, I can simply just say, starting from the beginning all the way into the end, in step sizes of 2, and that will grab every other letter. And you could use a for loop to do a reassignment as well, but slicing is a nice little trick to use here. And then if we run that, we get back hello world. So let's do a quick rundown of everything we just did, because there is a lot going on here. We started off by creating our attributes where we assigned a seed. That way we can shuffle the same way, the shuffled alphabet. We created an empty encrypted phrase string to hold. And then we set a true alphabet, which is just the list version of the lowercase letters. And then we created a random alphabet using random.sample as hinted right here in this comment. And then what we wanted to do was our encryption method. So we set up an output string that was empty. Then the next thing we did was for I in range length of message. So essentially for every letter or index position in the message, we concatenated to that string that actual letter at that point in the list. And then we added in some random sample of the alphabet. And since random sample returns back a list, we needed to index that letter out using 0 here. So we got something like this back. So we wanted to use this indexing to actually grab the output. And remember, if you're having trouble keeping track, you can always do a Python debugger set trace anywhere in this code so you can play around with the variables, or you can just use print statements. Then we have step 2, which was reverse a string. That one was pretty straightforward, just how to use slice notation for that. And then finally, we wanted to use the random shuffled alphabet to create a Caesar cipher. So we created this little holding variable called encrypted phase 2, where we created a list, range, length of the encrypted phrase. So essentially just a list of a bunch of numbers from 0 up to the index position of the encrypted phrase at the very end. And then we iterated through this list using enumerate. So for every index and letter in the encrypted phrase .lowercase, if we actually had an alphabetic letter, we did the switch here using the index position of the true alphabet and finding it in its random alphabet, the Caesar cipher. And then otherwise we had punctuation or other spaces, and we just kept it the same thing. Then we joined it all back together so we could return back the encrypted phrase. Then we have the decryption, and it works the same way except everything's in reverse order. We set our seed, we make sure we have the same random alphabet that was used during the encryption process. We create our decrypted message, we reverse the Caesar cipher by grabbing the index position of the random alphabet, then replacing it with the true alphabet, again checking for punctuation or spaces, and then we join this up by reversing it, and we also grab every other letter. And that's it for the encryption and decryption. That was definitely the toughest assignment you've had so far, but if you were able to successfully accomplish this, you're definitely ready for the field. We'll see you soon.